Good day, esteemed researchers and curious minds tuning in from around the globe. We're about to delve into the fascinating world of precise, zero-shot dense retrieval without relevance labels. This groundbreaking research challenges the conventional understanding of numerical relevance in language tasks, introducing a novel paradigm that leverages the power of language models to redefine relevance modeling. Stay tuned as we explore the innovative HyDE method and its implications in the realm of dense retrieval. Let's embark on this intellectual journey together. We're introducing a new paradigm of interaction that challenges the traditional concept of numerical relevance in language understanding and retrieval tasks. Our model, HyDE, creates a unique interaction between language models and dense encoder/retrievers, offering a fresh perspective on how these systems can work together. Now, let's take a moment to critique prior works. Dense retrieval has been a focal point of research, with a heavy emphasis on vector similarities and regression scores. However, we propose a thought-provoking idea. Could numerical relevance be merely a statistical artifact of language understanding? This question forms the basis of our research and the development of HyDE. Our research introduces HyDE, a novel method that leverages the power of InstructGPT and Contriever models. This approach delegates part of the relevance modeling and instruction understanding to a more powerful and flexible language model. A key advantage of HyDE is that it eliminates the need for relevance labels, simplifying the process. In terms of evaluation, we've used a variety of datasets. These include TREC DL19 and DL20, the BEIR dataset, and the Mr. Tidy dataset. Our tasks span across multiple languages, not just English, but also Swahili, Korean, Japanese, and Bengali. This broad coverage ensures our findings are applicable to a wide range of linguistic contexts. Let's delve into the problem we're addressing. Zero-shot dense retrieval, which is the process of retrieving relevant documents without any prior training on the specific task, remains a significant challenge. Traditional methods often model relevance scores between a query and a document, but this approach has its limitations. Now, take a look at the figure on the screen. It illustrates our proposed solution, the HyDE model. This model is unique because it doesn't require any changes to the underlying GPT-3 and Contriever or Contriever models. Instead, it introduces a new paradigm of interactions between the language model and the dense encoder or retriever. This innovative approach allows us to serve all types of queries more effectively. In essence, we're reimagining how we approach the problem of document retrieval, and we believe the HyDE model is a significant step forward in this field. Existing methods of document retrieval, such as dense retrievers and self-attentive re-rankers, rely on numerical relevance scores. These scores, however, might just be a statistical artifact, not truly capturing the essence of relevance. Our proposed solution challenges this approach. We aim to build fully zero-shot dense retrieval systems that require no relevance supervision. These systems are designed to work out of the box and generalize across tasks, making them versatile and efficient. We introduce a new paradigm in this field, focusing on the interaction between language models and dense encoders or retrievers. Instead of relying solely on numerical relevance scores, we delegate part of the relevance modeling and instruction understanding to the language model. This approach leverages the power and flexibility of language models, removing the need for relevance labels and offering a fresh perspective on document retrieval. HyDE, our proposed model, takes a unique approach to dense retrieval by decomposing it into two tasks. The first is a generative task, which is performed by an instruction-following language model. The second is a document-document similarity task, which is handled by a contrastive encoder. What sets HyDE apart is that it doesn't explicitly model a query document similarity score. Instead, it transforms the retrieval task into two natural language understanding and generation tasks. This innovative approach allows us to capture the concept of relevance in a different way, through the language generation process. In terms of effectiveness, HyDE has shown promising results. In many instances, it has proven to be as effective as dense retrievers that learn to model numerical relevance scores. Moreover, at the onset of a search system, HyDE offers performance that is comparable to a fine-tuned model. This is a significant achievement, as no other relevance-free model can offer this. In conclusion, HyDE presents a new paradigm of interactions between language models and dense encoders/retrievers, opening up exciting possibilities for future research and applications. Our research introduces a novel approach called Hypothetical Document Embeddings, or HyDE. This method is designed to revolutionize the field of dense retrieval systems. The beauty of HyDE lies in its ability to operate fully in a zero-shot manner. It doesn't require any relevant supervision, making it a truly autonomous system. Furthermore, it's designed to work right out of the box and has the ability to generalize across a variety of tasks. This makes it a versatile tool in the field of information retrieval. In essence, our goal is to create a system that is not only effective but also adaptable to a wide range of scenarios. Our research pivots around a novel concept called Hypothetical Document Embeddings, or HyDE. This approach breaks down the process of dense retrieval into two distinct tasks. The first is a generative task, where we feed the query to a generative model. This model is then instructed to write a document that answers the question, essentially creating a hypothetical document. This generative process is designed to capture relevance by providing an illustrative example. The hypothetical document may not be real and could contain factual errors, but it serves as a representation of a relevant document. This innovative approach forms the core of our research and has shown promising results in our experiments. Our research introduces a novel approach to dense retrieval, which we've broken down into two main tasks. The first task is the document-document similarity task. Here, we utilize an unsupervised contrastive encoder to transform the hypothetical document into an embedding vector. This encoder acts as a lossy compressor, filtering out unnecessary details from the embedding. The second task is the retrieval process. We use the embedding vector from the first task to search against the corpus embeddings. This process retrieves the most similar real documents. It's important to note that we're not explicitly modeling or computing the query document similarity score. Instead, we're leveraging the document-document similarity encoded during contrastive training. This innovative approach allows us to build effective dense retrieval systems without the need for relevance labels. In our research, we've explored a new approach to relevance modeling and instruction understanding. We've delegated part of these tasks to a language model, specifically an NLG model, which captures the concept of relevance through the language generation process. On the other hand, we've utilized a dense encoder or retriever to encode the hypothetical document into an embedding vector and retrieve the most similar real documents. This interaction between the language model and the dense encoder retriever forms the crux of our proposed system. A key improvement we've achieved is the removal of the need for relevance labels. This raises intriguing questions about the necessity of numerical relevance in language understanding and retrieval tasks. Is numerical relevance just a statistical artifact of language understanding? Or could a weak retriever suffice as language models become stronger? These are the questions we hope to explore further in our future work. Diving into the key results, we find that HyDE demonstrates an effectiveness that stands shoulder to shoulder with dense retrievers. In the early stages of a search system's life, HyDE can match the performance of a fine-tuned model. offering a unique advantage that no other relevance-free model can provide. As the search log expands, a supervised dense retriever can be progressively implemented, enhancing the system's capabilities. But HyDE doesn't stop being useful there. It continues to serve as a practical solution for less common and emerging queries, ensuring that the system remains versatile and adaptable. We've introduced a new paradigm in this research, focusing on the interactions between a language model and a dense encoder or retriever. This approach delegates part of the relevance modeling and instruction understanding to the language model, a shift from traditional methods. Our concept of relevance in HyDE is unique. It's captured by a natural language generation model and the language generation process. This raises intriguing questions about the necessity of numerical relevance in language understanding and retrieval tasks. We've implemented HyDE using InstructGPT and Contriever models. Our results show that HyDE can be as effective as dense retrievers in many cases, demonstrating its potential. Importantly, our approach removes the need for relevance labels. This offers a fresh perspective on language understanding and retrieval tasks, and we're excited to see how this can be generalized further to more sophisticated tasks. As we conclude, let's reflect on the HyDE model. We encourage you to compare it with other retrievers or re-rankers you've encountered. They may differ in architecture, training method, or task, but they all involve modeling relevance scores between a query and a document. HyDE, however, captures relevance through a language generation process. This raises intriguing questions. Is numerical relevance merely a statistical artifact of language understanding? Could a weak retriever suffice as language understanding and generation models become stronger? These are questions we hope to explore further. Now let's consider the practical use of HyDE. It's particularly effective at the onset of a search system's life, offering performance comparable to a fine-tuned model. This is a unique advantage that no other relevance-free model can offer. As the search log grows, a supervised dense retriever can be gradually introduced. As it strengthens, more queries will be directed to it, leaving only less common and emerging ones for the HyDE backend. This demonstrates the practical and flexible nature of the HyDE model.